students, in this video we are going to study about p block elements. Before going into the study of p block element, let's see the position of p block element in the periodic table. According to the modern periodic law, the Mendeleev periodic table based on atomic number. Based on the atomic number only, the arrangement of electron called electronic configuration written for all the elements. So, in the modern periodic table, all elements are arranged according to their atomic number and electronic configuration. Now, already we have studied about S block elements in 11th standard. Elements, their properties, physical, chemical properties, compounds and their uses, already we have studied. In this year, in 12th standard, we are going to study about D block element, P block elements and F block elements. How elements are grouped, how elements are classified is here based on the last valence electron present in what orbital. For example, S block elements means the valence electron is present in S orbital. P block elements means the p orbital, the valence electron present in p orbital in all the elements, and they possess incompletely filled p orbital. And here D block elements, the so the valence electron is present in d orbital. Here the F block elements, 4 of block elements are called lanthanides, and the electrons are subsequently filled in 5 orbitals are called actinides. Here lanthanide starts from lanthanum and ends with lutetium, 4 of 0 to 4 of 14, and here actinide starts with thorium, actinium and ends with lawrencium. Here the F block elements are also called as inner transition elements, as the incoming electrons are going to the inner 4 of orbital from the outermost level, and also 5F block elements. Also called as rare earth elements, as it's rarely abundant in nature. Then D block elements are also called as transition elements. Why D block elements are called transition element is as their properties are transit between S and P block elements. Now coming to P block element, what are P block elements? If they ask what are P block elements, define P block elements. P block elements are the elements which possess the incompletely filled p orbitals called P block elements. The P block elements present in 13th to 18th in the periodic table, and the general electronic configuration of P block element is ns2 np1 to 6. And here the 13th group, boron group, here it is a carbon group, nitrogen group, oxygen group and halogen group. Here this is the 18th group, inert gases. They have fully filled outermost shell according to the octet rule, but their properties are similar to that of P block elements, so they are grouped along with the P block element even though they contains completely filled p orbital. Now we are going to see the electronic configuration of each group present in the P block element. Now the 13th group, boron group, the atomic number is 5. The electronic configuration is 1s2, 2s2, 2p1. So 2s2, 2p1, the last level, Kl, it contains only one electron in the p orbital. And comes to aluminium, according to the atomic number 13, it contains 3s2, 3p1. Here the one electron in the p orbital. So on coming down, boron, aluminium, gallium, indium, thallium, novium, they all can here. This row is radioactive in nature. The P block elements, the last row is radioactive in nature. And here thallium ends with, according to the atomic number 81, 6s2, 6p1. Starts from boron 2s2, 2p1 and ends with the 6s2, 6p1. So all elements in the boron group contains 2 electron in the s orbital and 1 electron in the p orbital. So general electronic configuration of boron group is ns2 np1. And next one is carbon group. According to its atomic number 6, the electronic configuration is 1s2 2s2 2p2, 2 plus 2 4 plus 2 6. And silicon it is 3s2 3p2, germanium 4s2 4p2, ends with here lead 6s2 6p2. So all elements in the carbon group contains 2 electron in the s orbital and 2 electron in the p orbital. So general electronic configuration of carbon group is ns2 np2. Come to nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen atomic number 7, so 1s2 2s2 2p3, 2 electron in the s orbital, 3 electron in the p orbital. So phosphorus 15, 3s2 3p3, arsenic 4s2 4p3, 5s2 5p3, ends with 6s2 6p3. So nitrogen group, all elements containing 2 electron in the s orbital and p electron 3 electrons. So the general electronic configuration is ns2 np3. Oxygen atomic number 8, the electronic configuration 1s2 2s2 2p4. K shell is 1s2 2 electron, 2 plus 2 4, 4 plus 4 8. So sulfur 3s2 3p4. So ends with tellurium, polonium ends with 6s2 6p4. They all elements contain 2 electrons in the s orbital and 4 electrons in the p orbital. So general electronic configuration ns2 np4. Halogen fluorine, chlorine, bromine, iodine, astatine. And here fluorine atomic number 9, 1s2 2s2 2p5. So last electron 5 plus 2 last level 7. And here 2 electron in the s orbital and 5 electron in the p orbital. So 3s2 3p5, 4s2 4p5, 5s2 5p5, 6s2 6p5. All contain 2 plus 3, 7. So general electronic configuration is ns2 np5. So inert gases, here the fully filled last level neon 10, 1s2 2s2 2p6. Here 6 plus 2 8, first level 2 10, 2s2 2p6. The second level 6 plus 2 8, 6 plus 2 8, 6 plus 2 8. They all contain 8 electron in their valence shell. It's said to be stable according to octet rule, Coastal-Lewis octet rule. Having 8 electron in the outermost shell, valence shell is said to be stable. They all possess the completely filled stable configuration, but their properties are similar to that of p block elements grouped along with the p block elements. So now we can say p block elements all possess incompletely filled p orbitals. The electrons are subsequently in the p orbital on moving from left to right in the periodic table. Now see here 2p 1, 2p2, 2p3, 2p4, 2p5, 2p6. So this is general electronic this is the electronic arrangement or electronic configuration of p block elements according to their atomic number. And here the colored here the elements are given in color. Here the purple color is the elements are show metals, and here this are non-metals. And here the green color metals, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. It is in between, the transit between metals and non-metals called metallites. So these elements are the purple colors, elements are metals, and here the non-metals, and here showing them not metallites. So not showing metallic property and partial between metals and non-metal called metallites. So this is a general study of p block elements. In coming videos, we are going to study in detail about the compounds and uses and nature about p block element compounds.